This is a geometry review lesson, and we are going to talk about several things. I want to just touch on some things that you've probably heard before, and some of them might be new. We're going to talk about how to classify pairs of lines, and then we'll talk about special pairs of angles and symmetrical figures, and just two different types of symmetry. So that's what we're going to touch on today. So just you can call this, we'll just call it geometry. All right, so let's start with some different kinds of lines, pairs of lines. And can you think of any ways that two lines can be classified? Like if I were to draw these two lines, what could you tell me about the way they interact with each other? Well, those are intersecting lines because they cross. They have an intersection like on a road. Okay, so then what about this pair of lines? If you notice, they are never going to cross. If you keep going forever, they don't intersect, and so therefore they are parallel lines. And then the third kind would be two lines that when they cross, so they're intersecting, they're a type of intersecting, but they make a special kind of angle when they cross, and those are called perpendicular lines. And they form, there's four right angles in there. Usually we just draw the one. Alright, so those are our three different kinds. And let me also mention to you how a line is named. So if I have a line right here, and a line is really just made up of an infinite number of points that happen to all fall in a line, and they get so close together that they touch. But to name a line, we like to put a couple points on there, and so that we can call it something and we name those points. So I'm going to call that point A and that point B. So to name the line, you just name two of the points on the line, and then you draw a line with two arrows above it. So that's a way to name this line. We call it line AB. Now you can also call it line BA. So notice this isn't trying to show me what the line looks like which direction. Anytime you name a line, it always has that symbol above it. And you just have to name 2 points, any 2 points on the line. So let me give you a picture here, and you're going to practice this on your own a little bit later. These two lines are parallel, and then I've got a line here, and I didn't quite draw that perfectly, but we'll just assume that that is hitting it at right angles. And then let's draw another line coming through here. And why don't you draw this in your notes as well. And we'll name some of these different points on the line. Notice I'm kind of highlighting where they intersect as well. But, you know, you could have a point here. You could have points all over. Okay, so we've got point C, point D, point E, F, and G. All right, so let's practice finding different pairs of angles. And I think what I'll do is just write them over here. So let's find, can you name a pair of intersecting lines? Well, I see that this line right here intersects with two lines. It intersects with the top one and the bottom. So let's put that line FC. So again, you name it with that symbol, name 2 points on there, line FC. It intersects with line GE. Now, could we call this line CF instead of FC? Yes. Could we call this line EG instead of GE? Yes, you can switch them. So that's an example of a pair of intersecting lines, but there's all kinds of intersecting lines here. This line here, line ED, intersects with line CD, with the one going across the bottom. And even these two lines, line ED and CF, would they eventually cross? Yes, somewhere up in here. All right, are there any parallel lines? I even mentioned that. Yes, these two lines that don't intersect, we could call it line GE, we could call it line FE, we could call it line EF, EG. I think I'll just call it line GE because that's what we called it up there earlier. So GE is parallel to line CD. And then perpendicular, there are a couple different sets of perpendicular lines. So see if you can find them. So which one's perpendicular with GE? Remember, it has to hit it at a right angle. GE is perpendicular with ED. So right here, they're forming a right angle. So those are perpendicular. Where's another pair? Yes, the bottom line that's here is hitting this one, ED, is perpendicular. So we could say line CD and line ED are also perpendicular. Okay, so that's different types of pairs of lines. Let's talk about some special pairs of angles. All right, let's clear this off. So, angles. Now we know different kinds of angles, like acute angle less than 90, a right angle equal to 90, a obtuse angle more than 90, and you might know a straight angle. That just means a straight line. It's 180 degrees. But we can talk about angles as they match up together. There's certain types of angles, and there's three words you need to get down in your notes. The first one is angles that are vertical. Vertical angles. I spelled that wrong. There we go. Vertical angles. And those are angles that they share a vertex, and they're what are formed with intersecting lines, and they're diagonally across from each other. So draw two intersecting lines, and the angle formed, there's four angles here, and the vertical ones are the ones that are across. So they don't share a side, but they share a vertex. So this angle right here is vertical with this angle. And it turns out they're actually equal to each other. And they kind of look equal, even though I just did a quick sketch. And then here would be another pair of vertical angles. So vertical angles are congruent, and congruent just means they're equal to each other, that they're across like that. If we look over back with this other part we were doing, this angle would be vertical with this one, like right here and here. You could have vertical angles here. This one's vertical with this one. See how they're diagonally across. Okay, then another type of angles I want to highlight are called complementary angles. And it doesn't mean that they give each other complements. It means it's two angles that add up to 90 degrees. So they have to add up to 90 degrees. Now, they don't even have to touch. They can be in totally different locations. They just have to be two angles that add up to 90 degrees. So I could have an angle here, and let's say that that angle is 60 degrees. And then over here I draw a small angle, and that one is 30 degrees, they're supplementary because 60 plus 90, I'm sorry, 60 plus 30 is equal to 90. So therefore, we could say maybe angle B and angle C, we can name it by its vertex, are what we call complementary because they add up to 90 degrees. You can also have another way to find complementary angles. I'll draw this here. I can have something coming out like that. And another way to name angles is to put a little number inside of them. So maybe this is angle 1, angle 2, 3, 4, 5. So that's angle 1, angle 2, angle 3, angle 4, angle 5. And if I put this little notation here, that little box tells us that this is a right angle. And so what kind of lines are they? Remember, they're perpendicular lines. So angle 3 is a right angle, angle 4 is a right angle, angle 5 is a right angle. But if you notice, because angles 1 and 2 add up, they make a right angle. So and right angles we know are 90 degrees. Angle 1 and angle 2 are complementary angles. All right. Then the last type are called supplementary angles. And supplementary angles are two angles that add up to 180 degrees. So complementary, they add up to 90. Supplementary, they add up to 180. And so if we look like right here, back at this one, we have angle 4 is a right angle. Angle 5 is a right angle. Well, we know 90 degrees plus 90 degrees add up to 180. So therefore, angles 4 and angle 5 are both, together they form a pair that are called supplementary angles. What about 3 and 4? Are they supplementary? Yes, because angle 3 is 90 and angle 4 is 90. So we could put down here we said angles 4 and angle 5 are supplementary. We said angles 3 and angle 4. Well, what about 3 and 5? What kind of angles did we say 3 and 5 would be? They're vertical angles because they are formed by that intersection. They're across from each other. So they're vertical angles, but they're also supplementary. Angles 3 and 5 are supplementary because they're both 90. All right, so let's say another way, let me draw a line here. That's actually a straight angle. If I make a line coming off of there. Well, all straight angles, it's a half circle. And we know that a full circle is 360 degrees. So a half circle, half of 360, is 180. So therefore, we know that this angle plus this angle have to make 180 degrees because it's a straight angle. So if I were to tell you that this little angle right here, the small one, is 40 degrees, how could you find out what this angle is? Well, you know that together they're supplementary. They make 180. So what's left is 140. You just subtract 180 minus 40, and you can find that. So they're supplementary, the 40 degree and the 140, and you can find missing measures like that from a straight angle. So if I gave you, let's say we had an angle like this, and we'll say that it equals maybe 100 degrees. And then over here I have an angle, and it's 80 degrees. Would those two be supplementary? Yes, because 80 plus 100 equals 180. So they're supplementary. Okay, let's just practice something kind of like this again. Let's say I have a line going vertically, and then I draw a line coming up here, and I tell you that this angle here is 130 degrees. That's this angle, the big one, the obtuse. And you have to find this one. Well, it makes a straight angle, and we know straight angles are 180. So 180 minus 30, sorry, 130 would be, let me erase that one. Wrong thing. Take the 180, subtract the 130, we're left with 50 degrees. So our question mark, the small angle there, would be 50 degrees. 130 plus 50. Okay, so that gives you, I think that'll help you with your special pairs of angles. The last thing I wanted to go over with you is symmetry. So that's our third part. We have 3 parts. Now, symmetry, we have different types of symmetry. We have something called line symmetry, and we have rotational symmetry. Those are our different types. And let's focus on our line symmetry first. So line symmetry it's also called, another name for it is a reflection. So you're reflecting it over a line. And you may have heard that term, a reflection, like a reflection in a mirror. It's a mirror image. And with line symmetry, a line can be drawn where you could fold the image, and both halves would match exactly. So there's some figures have this kind of symmetry and others do not. So let's look at this triangle. We'll say it's an equilateral triangle. All the sides are the same. And because I could draw a line right here and fold it on that line and the 2 sides would match, it has line symmetry. It makes a reflection, one side to the other. If we had, say, the letter A, if I were to draw a line down the middle, does it cut it in half? Yes, it does. What about the letter, let's do the letter Z. Well, if I draw a line here, is it going to create a fold where both sides would be the same? No. Right here? No. That way? No. So that one does not have line symmetry. What about, how about just a circle? Does it have line symmetry? Yeah, you could draw the line there, you could draw it here, you could draw it anywhere you wanted to, and that would be line symmetry. Okay, so I think you get the idea. So, well, let's actually, were there any other lines of symmetry on this triangle? There was one here, but you know what? We could also cut it right on that angle. There's a line of symmetry, and then we could also cut it right there. So that figure actually has 3 lines of symmetry. Some are going to have 1, 2, 3. Some are going to have none. So you'll just have to check it out. You can try them and see. Okay, so then the other kind of symmetry I mentioned is called rotational symmetry. And that's really kind of what it sounds like, that you can rotate the shape. So the shape, or you could put image, can be rotated or turned, and it still looks the same. Now, everything is going to have 360-degree rotation symmetry because that's turning it 360 degrees is full circle back to where it started. But we're talking about rotating it like 90 degrees or 180 degrees, that type. And we want to see if it's symmetrical. So if I take something like, well, let's go back to that triangle we were using earlier, and we drew the line symmetry that it has. Well, it's like you put a dot right in the middle, and you want to turn it. And so if I turn it a little bit, will it end up, if all these sides are the same, wouldn't it turn and then it would look just the same? If I did a turn to here, and then I could turn it again, and it would still be symmetrical. So that would be an example of one that has rotational symmetry. What about the letter X? If I rotate it, will it get back to where it started before you go all the way back around? Yes, it will. So that just gives you an idea of what you're looking for. Some of them, like this triangle, had both line symmetry and rotational symmetry. So some of them have both. Okay, so that's what I wanted to touch on with the geometry. You have some sheets now that you can get out and work on and practice what you just learned.